All right, so here is a procedure for hypothesis testing using the critical value approach that we've been setting up all along. This is a little bit different than what your author has presented, but if you follow these 5 steps, you'll never go wrong. So we want to perform the hypothesis test for our population mean mu. We have to make some assumptions and probably validate these assumptions, but one, the data collection for your sample from the population should be a simple random sample. The next thing, the population should be normal, or we can relax that normality for large sample size. So I'm going to talk about this as the large sample size case. And sigma known. Again, in practice, we never know sigma, but as long as the sample size is large, we can use S, the sample standard deviation, as long as your sample size is large. Because again, don't forget we have the central limit theorem that also drives a lot of this. So the steps that I'd like for you to follow is, the first thing, we will state the null and the alternative hypothesis. Our second step that we will do is to compute the test statistic, and in this case it's going to be a z-test statistic. Later we'll get to a t. And then the next thing you should do is sketch the normal distribution, identifying the rejection region, the non-rejection region, and the critical values. And then step number 4 is to make the decision to reject or fail to reject the null hypothesis based on which region your test statistic falls. And then summarize your results in a formal statement. So these are the 5 steps that I'm going to follow, and as long as you follow these 5 steps, you can never go wrong. One point of condition that I would like to make regarding the conclusion of a statistical hypothesis test, and I want to make sure that we are very clear on the conclusions that we make. So first, when the data indicates that the null hypothesis is rejected in a hypothesis test at some significant level alpha, we can frequently express that fact with the phrase, the test results are statistically significant at the alpha level. So you can come back and say that there is a significant difference between my results and what's going on in the null hypothesis, because if you reject, then you're saying that there's a statistical significant difference. There's 2 types of differences we can take a look at: a statistical significant difference or a practical difference. The practical difference comes in the fact that mu under the null hypothesis and your x bar are not going to be the same. There's your practical. But the question is are they far enough apart to say that there is a statistical significant difference? So, for example, one day you can be driving down the highway, just zooming along past a cop, nothing happens, and then you go back the next day, you zoom past the cop, and boom, he pulls you over. As I was advised one time by a state trooper, that the state troopers here in Colorado will issue a ticket whenever you're going 10 miles per hour over the speed limit. So that's their critical value. When they clock you, and if it's greater than 10, you're in the rejection region and you're getting the ticket. All right? So if you're traveling, if the speed limit is 65 and you're going 70, then you're in that fail to reject region because you're not going to get a ticket. But if you're going, what did I say, 65, you're going 70. So if you're 65, you're going 80, guess what? You're getting the ticket. So this is kind of the difference. So, you've maybe heard the phrase or used the phrase, well, they're not exactly the same, but close enough for government work. That's kind of the idea of failing to reject the null hypothesis. Okay. Now, when you do reject the null hypothesis in the second bullet point, when Yeah, when you fail to reject, then you'll say that there is no statistical significant difference. So another couple of ways that we can rephrase our results: there is a statistical significant difference, or there is not a statistical significant difference. But note that when you fail to reject the null hypothesis, and this is something that I really want you to pay attention here, is this guy right here. When you fail to reject the null hypothesis, number one, we are not saying that the null hypothesis is true. Let me repeat that. When you fail to reject the null hypothesis, you are not concluding that the null hypothesis must be true. All you can conclude when you fail to reject the null hypothesis is there is not enough evidence to reject the null hypothesis. That's all you can say. So when you fail to reject the null hypothesis, again, I want to reiterate, you are not saying that the null hypothesis is true, correct, or the greatest thing since sliced bread, if you will. All you can say is that there is not enough evidence in the data to reject the null hypothesis. That's why we don't accept the null hypothesis. We fail to reject the null hypothesis. The data will tell you everything, and it'll tell you whether you should reject or fail to reject. And again, we're not accepting and we're not saying it's true when you fail to reject the null hypothesis. Now, when there is enough evidence in the data to state that the null hypothesis is not true, then we can say that we will go ahead and accept the null hypothesis. Again, we're not saying, the alternative. And again, we're not saying that the alternative is true. It's just that we found enough evidence within the data that says we need to move from the null to the alternative, that something is going on in the data to say there is some sort of a difference going on in this situation. Okay. Yes?
Question. So you're not saying that the alternative is true, but you can use the word accept.
Yes, we say
you
right, when you move from the null to the alternative, then you are rejecting the null and accepting the alternative. You can say that and be safe. But when you fail to reject the null hypothesis, that's exactly what you're doing. You're not accepting it, and you're not saying it's true. You're not saying it's right or correct or any of these other ideas. All we're saying is there's not enough evidence in the data to reject, so we fail to reject. All right, so let's play. And then, if you will, if you have the lecture slides with you, please keep that 5-step process handy, because I'm going to march right down there, and I would like to have some participation. So if you didn't bring these, you may want to look on or share with somebody that has the 5 steps as well. But as we go through this first example, we'll just kind of waltz down the hypothesis testing procedure together. So here we want to test the claim that the population of sophomore college students has a mean grade point average greater than 2.25. A sample of 150 sophomore college students revealed that their average GPA is 2.35 and the population standard deviation is 0.8. So use a significance level of alpha equals 0.02. All right, so to perform the statistical hypothesis test, step 1, recall step 1 says we need to state the null and the alternative hypothesis. So here we come back over here to our little paragraph, and we read that right here in the first sentence, in this case, test the claim that the population of sophomore college students has a mean grade point average greater than 2.25. So is that first sentence a sentence of difference or a sentence of non-difference? Of difference. So is this going to be the null or the alternative? The alternative. So our alternative is going to be mu is what? Greater than 2.25. So that means our null hypothesis mu equals 2.25. Remember, the null hypothesis just means that there is no difference. It's a statement of no difference. So there's step one. Step two is to compute our test statistic. So we have a sample of 150, so we know we're going to use a Z or a T. May as well get used to answering these questions now. Z. So we have a Z test statistic, then is equal to X bar. So X bar is 2.35 minus mu under the null hypothesis, which is 2.25, times the square root of n, which is 150, divided by the standard deviation, which is 0.8. So if you want to crunch that really quick, you should come up with a test statistic of 1.53. So 2.35 minus 2.25 times the square root of 150, enter, divided by 0.8. So 1.53. All right, so we have our test statistic. So step three. So step three is we have to set up our standard normal distribution. So this thing is centered at 0. Now, the direction of our test, is this going to be a two-tailed, upper-tailed, or a lower-tailed test? An upper-tailed test. And we have a significance level, alpha is 0.02. Since this is an upper-tailed test, then that means that this shaded region right here is going to be 0.02. So that means we need to come up with this z-score right here. So again, all you have to do is determine that using either the charts or the tables. Doesn't matter to me which way you do. So if the upper tail is, we've done these like 1,000,000 times now, so you know to look up 0.98 for your area, or you can use the calculator and use the inverse norm command. So we go distribution, menu option 3, and remember this thing always returns back the left-tailed area just like your charts do. So if the upper tail area is 0.02, that means the lower tail must be 0.98. Right? So it comes back and tells us we have our critical value then is 2.05. Okay? So now we have to find out what region our test statistic falls in. So let's just note that our test statistic is 1.53. So our test statistic is right here. So does our test statistic fall into the rejection region or the non-rejection region? The non-rejection region. So step 4, we will come back and say we will fail to reject. So finally, for step 5, to formalize our results, we can come back and say at alpha equals 0.02, the data indicates that the average sophomore GPA is not greater than 2.25. Clean this up a little bit. It's like writing all over the chalkboard, isn't it? All right, so there you have it. That's all there is to hypothesis testing. Step number 1, set up the null and the alternative hypothesis. Step number 2, compute your test statistic. Step number 3, sketch your rejection region, non-rejection region, and include your critical value. And then identify which region your test statistic falls in. Step number 4, based on where the test statistic falls, make a conclusion. So here we fail to reject. And then step number 5, formalize your results. At alpha equals 0.02, the data indicates that the average sophomore GPA is not greater than 2.25. Okay?